Okay, so we'll continue where we left off in the last session on data displays. So we got done talking about scatter plots, that they compare to quantitative to numerical variables, okay? And the purpose of a scatter plot is to see if two variables correlate or relate to one another and how they relate to one another. So scatter plots are a good way to answer questions about correlation. So let's say you have a question. Is there any correlation between how much it costs to make a movie, the production budget, and how much the movie makes, so worldwide gross? So I pulled this information off the internet where I have 5 movies, the production budget, and the worldwide gross. And so the first thing you do, scatter plots are plotted on an XY plane or on the coordinate plane. If asked to graph one, we would provide one for you to use. And in this case, we're wondering if the worldwide gross depends on the production budget. Okay, so this would be production budget would be our X, and worldwide gross would be our Y. So the production budget is our independent variable, and we're wondering if worldwide gross, our dependent variable, is based on that. So you would have to label your X and Y axis. It's done on here for you. So production budget is X, worldwide gross is Y. So what you do is essentially this becomes an XY pair, where X is our production budget and Y is our worldwide gross, and that's how we plot the point. So for instance, starting with Avengers Endgame, our production budget is $400 million and our worldwide gross is about $2.8 billion. So we would go on our x-axis to $400 million, it's probably over here, and it grossed $2.8 billion. So this dot here represents Avengers Endgame. Okay. Next, Pirates, it had a budget of $379 million and it grossed just over $1 billion. So 379 is over here somewhere, and it grossed just over 1 billion. So this would be Pirates of the Caribbean. And you could keep going. 365 million. This is going to be Avengers and Age of Ultron. Star Wars had a production budget of 306 million and grossed just over 2 billion. So this would be Star Wars, and then Avengers Infinity War. So if we were to try to see if these correlate to one another and try to draw the line of best fit, it would be pretty hard to do because we've got some values over here where the production budget was lower. So for instance, take Star Wars. The production budget was lower than Avengers Endgame by almost 100 million, but it didn't gross that much less. Okay, so this would be hard to draw a line of best fit, but I wanted to show you how a scatter plot is working. You take two numerical values and you're plotting it as an XY pair in order to come up with your scatter plot. Okay, a couple of things on correlation. So I mentioned that correlation does not equal causation, and there's other explanations. So whenever I'm given something, I always think of, well, what else could it be? So for instance, possible explanations for correlation. So I have a graph here that shows the divorce rate in Maine over time versus the per capita consumption of margarine over time. So on the bottom, we have the years. Pounds of margarine consumed is going down, and the divorce rate's also going down. So does this mean that the consumption of margarine is causing the divorce rate to go down or vice versa? Probably not. This would be a case of where it's a coincidence. There used to be this website, I don't know why they took it down, called Google Correlate, where you could type in two things and Google would run its Google machine and spit out a correlation for you. Okay, but that's gone. Reason number 2, so for instance, we have another scatter plot that has to do with along the X, sunglasses sold and ice cream sales. So as the number of sunglass selling increases, the number of ice cream sales are increasing. What could it be? Is the purchase of sunglasses causing ice cream sales to go up? Probably not, but in this case, we have the same underlying cause. It's hot. People are buying sunglasses and ice cream. Okay, so in this case, one's not causing the other, but the same thing is going on that might be causing each to go up at the same time. And then the last reason is one might actually cause the other. So here we have a graph showing that the insurance premiums of people who text while driving is going up over time, while those, I guess, are not texting and driving over time. Okay, and this is a case where one may cause the other. Okay, so 3 reasons for correlation: coincidence, same underlying cause, or it might be true that one causes the other one. Let me go into data display. So I'm going to talk a little bit more about data visualization in this section. You don't necessarily have to copy it into your notes. It could be helpful when you're determining data displays, but also when you're intaking information around us. As I mentioned, we're in a quantitative world where we've got a lot of numbers and we've got a lot of charts and figures around us. Okay, so what is data? Data is defined as factual information, measures or statistics used as a basis for reasoning, discussion, or calculation. By the way, this was created by one of our librarians, and we got her permission to use it. I don't know if her permission slide is in here, but it's from Hillisang at UNLV. Okay. So data is defined as factual. If data is defined as factual information, should we accept it as objective truth? And this is something that I would have you all discuss or talk about. Okay. It's an interesting question because in a way, facts change over time. There was a time in our history where we thought that everything else revolved around the earth, that the earth was the center, and we found out that it turned out to be the sun. And so, data is important. It's important to understand, but perhaps it's important to keep an open mind as well as we find out more information. Science changes over time as well as we get more data points or more values, or as things change around us. Like I said, we have that example where we all thought that the world revolved around the earth, or that the earth is flat, things like that. Okay. Common ways data is used to mislead. So number 1, misrepresented visually. So if you just look at this bar graph, the bar for people on welfare is much higher than the bar for people with a full-time job. However, when you look at the numbers, they're not really that far apart. Remember in a bar graph that the bars have meaning. And so in this case, one not being that far from the other, there shouldn't be this disparity in the size of the bars. Number 2, dealing with numbers. So on the left-hand side, we have a column, most dangerous cities, total murders in 2014. The wrong way to think about that is just to take the numbers. So Chicago, 407, New York, 328, Detroit, 324, etc. But the right way to think about it is the term that's per 100,000 people, or we talk about the term per capita. So for instance, if we start leveling the playing field here a bit and say, okay, well, how many murders were there per 100,000 people in the cities? It comes out differently with the top and the bottom. This is also something that's really important when talking about COVID cases as well. I remember a while back, there was a news headline that said the U.S. surpassed Italy in the number of COVID cases. And while I'm not saying that the virus should be here and I don't want it to be here, it makes sense in a way. The U.S. is bigger. We're more densely populated. And so those types of things matter. Per capita is important to think about when you're dealing with numbers in cities. Another way that data is used to mislead is by using 3D figures. So 3D figures distort the images. In the chart on the left, it looks like the biggest slice is the slice that represents those who are Muslim. But actually, if this is a 2D graph, you can see the slices a little bit better. So 3D graphs tend to mislead. Number 2, cherry picking data and only including data that conveys your point. So this kind of happened when I was talking about the scatter plot and the movie budget. Not because I wanted to mislead you, but because for sake of time and demonstration and what I had to work with, I only chose 5. But if you would have chosen 100, maybe the correlation would have come out differently. So here we can see Twitter stock from 2014 to 2017, and it goes up and down. Okay, so the trend, it goes up, it goes down, it goes up and down and up and down. However, if I were to show you this, it looks like Twitter stock is doing pretty well. It goes low, low, and then it goes up. Well, the difference here is that this chart is only going from March to May, a 3-month span, whereas the previous chart was looking at, over the entirety of time. And so depending on, this chart isn't necessarily bad if you're transparent to say this was our 3-month stock, but it depends on what's being said with it, okay? The wrong kind of graph. So drafts of first round picks using a pie graph for numbers. Remember, pie graphs are for percentages and everything should add up to 100. The other issue with this is that Ohio State is 64, but it's like less than half of the pie. Okay, so a better way to represent it would be to use a bar graph. Venn diagram. So I think Venn diagrams like this are pretty funny. But usually Venn diagrams are for numbers. Let's see. So visualizing data correctly. So there's a couple of just kind of key things to keep in mind. Determining what your goal is and what type of data that you have. Okay. And so different displays, if you're talking about visuals, some type of bar graph or circle chart might be helpful for that. If you're talking about data where we have numerical variables or continuous variables, some different types of charts might be helpful for that. Let me know what questions you have on data displays.